Well, this is really a good example of what happens when you're talking over beers on vacation when you're cooking your meat in Maui. That's how I met Daryl, and we didn't have anything else to talk about, so we thought we'd talk about our work that we weren't doing at the time, and now I'm here, so I hope it's worth it. I'm a bit of a one-trick pony. I found when in my own experience, my own education, the more you drill down on a subject, maybe the broader your perspective becomes on the world, and I hope that's true, because when it comes to clean energy, I know there's a lot to know, so all I know about really is photovoltaic and solar. I know a bit about wind and a bit about everything else, but I know solar. And so really solar's gone from, I thought I'd talk about solar as a case study, talk a little bit about how that has evolved, maybe a little bit, give you some insight as to where I think we are in sort of the technology S-curve, sort of our development and where we may be going in the next 20 to 30 years. You know, we started as a niche application, really niche applications. I think the first large-scale application was for forestry towers. They wanted to have some sort of power out there to get an AM radio for the forestry fire watchers to make, if there was a fire, they wanted to have power to be able to say fire started, to really clean energy. And it's really moved in that probably very quickly in the last 20 years. It's an industry that's very fascinating. I'd like to say I probably am lucky. I don't even know that I'm good, but the technology grows at a rate of 50% a year, and every time we double our capacity, we reduce our cost by 20%. So that means roughly about every year and a half to 2 years, we reduce our cost to bring electricity to the market. And so it happens very quickly, and when you're a part of it, it's really exciting. And I can even look back when I started this 6 years ago at who the major players were in this industry, and none of them are even in the top 5 now. It changes that quickly. It's if I went back, it would have been like oil companies were dabbling in it, like BP and Shell. They'd mostly bought technology from university labs in the United States, and they became like the players, I guess, for these kind of niche applications. And now it's companies you never even would have heard of, but that have come as products of programs in their local countries that really want to encourage renewables. And so they sought the sort of model that we're not going to pick winners, but we'll create a market, and if we can encourage a market, then we will see innovation, and we'll see entrepreneurship, and we'll see development. And that's really what Germany did, and so Qcells is a dominant player there. Conergy is a dominant player there. One in 10 solar panels sold worldwide are sold by Conergy. So I got to go from being this guy tinkering away in Edmonton, Alberta, to a part of a global player. And in China now, we've got Suntech Power, and Japan has all their major manufacturers. Even just Samsung just recently said they're going to get into the Ontario market. Ontario has modeled an incentive program after Germany's, and that launched last Thursday. So I was kind of busy trying to react to that, which is pretty big legislation for us. And what has happened in this period of time in our industry is we've really, at the beginning is how can we reduce the cost for polysilicon wafers, and now the question is how can we reduce the cost for polysilicon wafers. Nothing has changed on that front, except that it's not all polysilicon anymore, and we're finding ways to remove the materials in the modules. And I brought some toys for people to come see, but I mean, this technology, whether in the cell inside when we talk about it, isn't like a biological cell, but it's just a unit, and that is an individual power generating unit. And we put them into modules, we encapsulate it in glass and some substrate material, and we put it inside aluminum frames. If you can get rid of the glass or the substrate material or make it cheaper, you can get rid of the aluminum, then you've got yourself a winner because you found a way to make it cheaper. Or if you can use less silicon, or if you can cover less of the surface area with the conductive material, then you've also got a winner. And so there's these things that will win. If you can get cheaper material to go into it, then you'll get a win. And it's much like, I thought it was interesting that we started with semiconductors, because I remember Ryan and I being in my warehouse and this moment of like clarity when he realized he's got a semiconductor that makes light. If you can I call it light in the lead world? I don't know. And I've got the semiconductor that makes electricity, and we can work in this nice DC power cycle. That's right, perpetual. It's going to happen right here in Edmonton, probably started here today. So I thought I'd just tell you a little bit about some of the players that weren't here 6 years ago that are here today and what they've done that got them up to speed and ahead of the game. We've got SunPower, First Solar. These are American innovations, and Enphase, an American innovation. We've got Sanyo. We've got a Japanese innovation there. SunPower, what they did was they've done a couple of really cool things, but they took really high efficient cells. And whenever we measure efficiency for our cells and surface area, we actually, the methods that we use were set out by NASA, because NASA was one of the first users of our technology. And they would just buy the cells. They didn't care about the whole module and anything like that. They just wanted the cells. They wanted individual generating units. And so the way we measure the kind of quality and productivity of a surface area, we call that efficiency. And so at SunPower, they got rid of this stripping we see here on the front of the module, and now all of a sudden you got more surface area that gets exposure to the sun, and you get more power out of that surface area. It makes them the most efficient in the world. Slightly. They're just behind Sanyo. But so they use very efficient cells, and they cleared up more of the surface area. They've also done something with positive grounding that is part of their process, but they've already, I don't think that really was a major improvement on the technology, just is something that's part of their technology. We got someone that First Solar, who, in the heartland of coal-burning Arizona, they they use Quebec cadmium telluride, and they ship it down to Arizona and over to Germany, and Alex talked about thin film from Nano Solar, so First Solar is really out there ahead of them, and they're very large commercially, and they use a lot less semiconductor material. They basically roll it out and bond it to glass, and then you've got a really great panel. And their real winner is that they are lower cost. And right now they are the most cost competitive product out there in the market. And then you got Sanyo, and Sanyo's done a couple of things that was really interesting. One thing they did was they made it so that you can use both surfaces. Because if you look at the back, it's like no light gets here, nothing gets used on the side. So maybe on a nano scale, people in the room are smarter than me will find ways to use more surface area of the materials that go into this, what appears like a flat surface. Sanyo wasn't that smart, so they said, well, what if we just use the back side of it? And so that's what they did, and it's really remarkable. If you've got a module aiming south, and it's at a tilt angle with the latitude of the area that you're at, you get 30% more production just by the reflection off of the material behind the module. So great way to make more power with less cost.